Yeah, today I'd like to present to you the project that, well, kept us entertained during the lockdown back in March. And to begin with, the title is, as you already said, Voice Assistants in Hospital Triage Operations. So I think we could start by giving some definitions. Well, I guess the majority of you know what a voice assistant is, which is, just to be clear, a software capable of interpreting human dialogues and answering through synthesized voices. But what is rather unknown is that some market researches have shown that the public is pretty interested in seeing these technologies applied to healthcare. In fact, as this research from VoiceBot from last year shows, even though the 92.5%, so the majority of people never use the voice assistant in healthcare use cases, the majority of the interviewees would like to, as in fact the 53% would like to, and the thing that is most interesting, I think, is that even the elderly, even the most aged people, like 70 plus people, are rather interested in using these technologies. And well, now that we've defined what a voice assistant is, I should talk about hospital triage operations. So, the term triage was born during the Napoleonic Wars, so in 19th century, to classify soldiers who were wounded during battles and, well, only treat those who could survive that injury. And well, even though it was born during max emergencies, during wars, it is today used somewhat in every hospital, every ER room, to classify the patients and cure them faster or slower based on the urgency of their injury. And well, Italy hasn't adopted a standard, but generally we could talk about four codes, which are color codes, and we go from red to white, which is red means critical injuries, with possible failure of vital functions and immediate access to the treatments. The yellow one means potential life risk, but the treatment can be delayed from 15 minutes to 30 minutes. Green means postponable medical evaluation, so let's say, for example, a fracture. And the white means the patient is not at risk. So, well, that is where the punto bianco term was born, which is people with no real emergency, which can be cured by the general practitioner, to just say. So, how is triage done? Well, the most used protocol in Italy is the CESIRA, which means consciousness, hemorrhage, shock, respiratory failure, fractures, and other symptoms. As you can see in the bottom of the slide, we go from the green code to the red code and to the yellow again, which is if the patient can walk into the hospital on his own, it's basically a green code. And the other things, well, they are pretty urgent. And well, the COVID-19 pandemic, as we all know, has changed a lot of these procedures since, well, people needed to be contained and positive patients had to be kept separate from the negative ones and from each other. So, well, the global pandemic we've all seen, well, changed these procedures really, really bad. And well, this project is solely based on Mycroft, which is an open source voice assistant. So, well, the project was born due to the total absence of non-proprietary voice assistants. If we think about Alexa, if we think about Google Assistant, well, it is all proprietary software, so you can't really work on it in an easy way. And well, as you probably all know, the term open source, well, it characterizes software with publicly available source code, which ensures security, collaboration, support, easy integration with existing systems, and, well, lots of really good things. And the Mycroft project started in 2015 after a crowdfunding, and it is pretty supported by the community. In the moment that we're talking, they have more than 4,000 stars on GitHub. So, well, it is pretty known. And, well, how does a voice assistant work? The first step is the wake word recognition, which is like Alexa, which is like, hey Google, and I think something will trigger right now in my room, but that's okay. And then we proceed to the speech to text, which is the recognition of the speech of the human to text. Then we parse the intent, so the computer decodes what the human wants. A textual response gets generated, and then the text-to-speech engine speaks the textual response. The great feature of Mycroft is its modularity. So every possible use case is encoded in a separate module which is named skill. So we might have, for example, a storytelling skill, a weather skill, a calculator skill, and coding new skill is pretty straightforward, since you just have to use the Python class Mycroft Skill, and you can just expand that by adding handling methods and so on. Mycroft makes some tools available like Pedacious, which is the intent parser, or like the text-to-speech engine, the speech-to-text engine. And the agent's responses are coded in files which contain phrases, example phrases. So, what does this agent do? Well, when the patient requests help, the agent starts an interview asking about the symptoms, the anographical data, pain evaluation, so basically what a nurse asks when you enter an hospital. And then it assigns a color code based on the urgency of the injury, and then it saves all the fetched data and the inferred data to a JSON file, which, well, you could use pretty much every standard you could think of, but JSON is pretty well adopted everywhere, so it makes integration with maybe existing systems in the hospital pretty easy. And, well, if the symptom is compatible with the COVID-19, a screening is initiated, so the patient gets asked if he has a fever, if he has a sore throat, a cough, shortness of breath, had contacts with COVID-19 positive patients, he misses smell or taste, and basing on the patient's answers, a score is generated. So this score states the plausibility of infection. This first, let's say, use case is documented in this video, which is 2 minutes long, and I will play it. I hope you can hear it.
Puoi aiutarmi?
Prima di tutto, lei ad avere bisogno.
Esatto.
Potrebbe dirmi il suo sintomo più importante?
Ho la febbre.
Hai la febbre, quindi. Ti sei misurato la febbre di recente?
Sì.
Per favore, dimmi a quanto hai la febbre.
37,8.
Mi serve qualche informazione aggiuntiva per la diagnosi. Però ti farò alcune domande a cui rispondere sì o no. Hai male alla gola?
Sì.
Soffri di raffreddore?
Sì.
Noti un affaticamento quando respiri?
No.
Hai la tosse?
Sì.
Sei stato a stretto contatto con persone affette dal nuovo coronavirus?
Sì.
Fatica a sentire i sapori e gli odori?
Sì.
Stiamo chiamando un medico. È possibile che tu sia infetto da Covid-19? Mi potresti dire quanti anni hai?
22.
Se hai altri sintomi da segnalare, per piacere dimmeli.
Non ne ho.
Su una scala da 1 a 10, quanto dolore prova?
7.
Ora dovresti dirmi il tuo nome completo.
Simone Montali.
Il tuo nome è Simone Montali, vero?
Esatto.
Grazie per la pazienza. Recati al banco, Yellow.
So, ignoring the fact that the yellow banco is not actually existing, but this is pretty much how it works. This is an example of an handling method. So what it does is basically it shows an image on the GUI, then it saves on the medical record the informations which are well connected with the symptoms that the patients declared, a color code, and then it speaks a response to the patient. But some of you may ask, what if the symptom isn't part of these are coded ones? So, well, we may need a more statistical approach. So, fallback skills are a subtype of skills that gets triggered when no other skill catches the intent. So they are initialized with a calling priority, and well, if a fallback skill catches the intent, the calling stack stops. This type of skill doesn't relegate us to a specific request, so we can just catch the intent and analyze it in a later time. So, well, you probably all know what natural language processing is, but well, it is a subfield of linguistics, computer science, and artificial intelligence that basically interacts with human dialogue. And the purpose we have now is creating algorithms that analyze the natural language, and more specifically, we want to classify an input text to a symptom category. So when a patient declares his symptom, we can send him to the right hospital ward. The first thing we have to do is, well, get a dataset. So, well, searching the web, we found the dataset on Kaggle, which is basically what we need, because it contains almost 8,000 patient requests, which are categorized in 20 categories like cold, back pains, shoulder pains. And well, since the voice assistant had to be in Italian, the first thing we had to do was translate these requests. And we used a Python library, which is Google Trans, since, well, to be completely honest, I didn't want to pay for the Google APIs. And, well, that's it. And the classifier was implemented using the FastAI library. We created a recurrent neural network, which is the type AWD-LSTM, which is a recurrent neural network which has long short-term memory and weight dropout instead of activation dropout, and a special type of stochastic gradient descent, which is based on the average instead of just one example. And the great thing of this FastAI library is that it enables us to export the model and then use it without having to retrain it. So it's pretty useful because, well, we can just register a fallback skill in the agent and then use the model we trained on, let's say, Google Colab, so that we don't have to train this model on the hardware we have on the agent. And well, the agent fetches the severity and the GUI item to be displayed from a JSON file, which we manually created. And if the patient confirms that the agent understood well the symptom, well, the automation just proceeds as before. A third use case we might consider is that sometimes the patients just want to know some information. Let's say we all know when you go to the general practitioner and there's, well, a waiting room full of people that just wants to ask the doctor if their cough is normal. And well, I think that this could maybe fasten things up a bit. So the first thing we had to do was look for authoritative medical data, which is, well, you cannot download things from Wikipedia if you have to show them in an hospital. And well, the Italian Health Ministry surprisingly has a website, and this website, even more surprisingly, contains really good information. And well, there's this free medical encyclopedia. Well, I have doubled the medical word, but yeah, sorry about that. And well, we can automate the download of these informations in two ways actually, because we firstly started with an API approach, which means we set up an HTTP server, and then we could query this server, and it scraped the web page from the term we were looking for. But a more fast approach is the periodic one, so that, well, we scrape the informations with Selenium, which is basically an application testing framework which enables us to automate actions on a web page. And, well, easily we defined a cron job, which is a periodic job, to just download these informations every day. So, having downloaded the informations, we could easily save them to a JSON file, and well, all we had to do is just define an intent in the Mycroft Skill, which had to extract the pathology name from the intent, and well, look for a best match in the database, so that if I asked about tumore ai polmoni, it shows results for cancro dei polmoni. And well, if useful informations are found, the agent then asks the patient what type of knowledge is needed, like symptoms, cures, prevention, and that's it. So the last thing we have to question about, I think we have to question ourselves about, is what are the technical requirements? So what devices are capable of hosting this software? And ultimately, will it run Doom? So, since the TTS and STT, so text-to-speech and speech-to-text computing, is cloud hosted on Google servers, the most computationally costly operation is the intent parsing itself. And even though Padacious requires neural network training, which is pretty costly, this only has to be done on the bot start. So, well, you can just start it 10 minutes before and then it can work all day. So the negligible hardware requirements make installing this agent pretty possible on nearly every computer built in the 10 last years. So even on cheap hardware like the Raspberry Pi. And this makes these projects cost pretty low, and well, it makes it affordable for nearly every hospital in the world. Let's think about third world countries, let's think about mobile health clinics. It can be pretty useful, I think. The only requirement we need is that if you need the GUI, you have to install KDE Plasma, which is a desktop environment which is free, open source, and pretty good, I think. Even though I prefer GNOME, but that's just small talk. So, to conclude with, tools like this agent could be, I think, a game changer in today's hospital, which are often crushed by the lack of staff, economical resources, and IT infrastructures. Because, well, an hospital needs stability and not innovation, I think. Well, it needs it, but I think stability is more important than innovation. And I think this is what made hospitals ignore innovation for years. And well, the open and expansible design, beyond being ethically correct, I think, well, it makes the integration with existing infrastructures pretty easy, and the safety enhanced and the reliability sufficient, I think. A better dataset could really improve this thing very much, because, well, the dataset was not that good, and if we had a better dataset, we could just use one single skill with the classifier, ignoring the hard-coded one. And I think a great part of this thing is that translating it to other languages, well, it could become a great tool for immigrants and tourists and people who do not speak the main language of the nation they're in. And well, just in the end, automating the most impersonal operations could, well, save nurses and doctors a lot of time, which means basically they can cure people better, they can cure more people, they can do great things. So, well, the source code is totally public. You can find all the things we've talked about on GitHub. Well, this is just a redirect on to my GitHub, but yeah, it's all on GitHub. Start it, please. We need stars. And if there are any questions, here I am.
Okay, thank you, Simone, for your presentation. There is already an hands up. Viviana, please go on with your question.
Right, great.
Yeah. Thank you for your great presentation and the very interesting work. I was curious about the translation of the agent into different languages, because I think this is something that should be done. And I was wondering if you was thinking of doing this at the design time, so having pre-compiled translations of the answers and the interaction, or at runtime by taking advantage, for example, of multilingual ontologies or something different, but a runtime translation?
Well, this is a great question, and I think, well, translating it during runtime would maybe be possible, but I think it slows up things a bit. But, well, if it could be done faster and if it could be integrated in Mycroft, since Mycroft pre-builds the intent files on the start, so in the way it is built today, doing this with Mycroft would be pretty impossible. But I think in the future, translating it at runtime could really make it lighter and pretty good, since it could be, I mean, it could speak every language in the root instead of just the ones we think about. So, well, that could be a pretty good improvement, but at the time, right now, it's nearly impossible. But yeah, that's a great improvement.
Thank you for your clear question.
Thank you.
Answer. Thanks.
If there is no more question, I actually have one. If I well understood your work, you're essentially employing a speech-to-text module, and which is then trained on a dataset which is taken from Australia, which means that it is in English.
Yep. Correct.
So there are two critical steps in my perspective. One is the speech-to-text phase, and the other one is the translation phase, since you used Google Translate, which is an automatic tool. So what is the impact of mistranscription or a mistranslation in work?
The speech-to-text is done by Mycroft itself, and it is done by the Google APIs, which are pretty good, as we all know. But the translation itself, it created some problems, since, as I said in the presentation, the dataset was not that good. So while translating, well, even the English was not too good. So while translating it, we had a little problems with essentially the fact that Google didn't recognize the phrases, and it didn't translate the phrases it didn't recognize. And this, well, reduced our dataset from 8,000 examples to about 2,000 translated ones. Because when that Python module didn't it didn't recognize the sense of a phrase, it didn't translate it. So, well, it deleted lots of examples, but we achieved an accuracy of about 60%, which is not great, but it kind of works.
I see. Thank you.
Thank you.
Really clear. Any more questions? Okay, so I would say the session 4 is over. Thank you all for your attending. The next appointment is at 4 o'clock for the meeting of the AI per IA group. Thank you all for your attention.